Hello all, welcome back to my channel and this is Harish Kulkarni. So today we are going to learn about searching algorithms. Okay, so what are searching algorithms? Generally in general term, what is meant by searching? Like we are going to search in the sense we are going to search for any element or anything or in that, right? In the same way, in the algorithm perspective or in the data structure perspective, now let's say you have a huge data. I mean, you have a book, right? In that book, you want to find out one particular page, right? What are you going to do? So, for example, if you find a topic in a book, right? So, I think it will be helpful if we have a what do you call in the first page if you have some like this page has this information, right? So something similar to that way, right? It helps you in a better way, right? So something in that way, we can actually have two types of algorithms in and actually in data structure. Okay, so what are those? We'll just check in I mean in just a couple of minutes. Okay, so first of all we'll just try to understand what is searching, right? So searching algorithms are, there are two types of searching algorithms. One is linear search and the other one is a binary search. Okay, so what is linear search and what is binary search? Okay, so what is linear search? Linear search is a sequential searching algorithm that is used to find an element in a list. Okay, now for example you have a list or an array. Okay, in that array you are sequentially searching. It means that you're trying to search for 0th element, first element, second element, third element, right? Now for example you search for a key called 30. So where is 30? You first start with the index 0. So this is the index 0. Okay, this is the index 0. Then you have index 1, then index 2, then index 3, this is index 4, then 5, 6, 7 and 8, right? So you compare each element with the key. You compare 10 with 30. Is it equal? No. You compare 50 with 30. Is it equal? No. You compare 30 with 30. Yes, we found the uh, we found the searching key, right? So then we just return that target index, right? So first of all, what we should do, what we have learned in our previous video, we should write an algorithm, right? So how are you going to write? To search for a given element using linear search, follow the, how do you watch? You first traverse from the starting of the data set. So you start from the starting of the data set, right? Compare the current element, that is 10, with the target, the key element. Okay, if the element is equals to the key, you return that index. Else you just increment the index, repeat this to the step 2, 3, 4 until you found the element. If you found the, if you have reached the end of the list and we did not find the element which you are trying to search, right? We say element not found, or we say -1, right? -1 generally it means that element is not found. Okay, so we'll just try to replicate this using a code. Okay, now let's check this here. Whatever we discussed here, this we'll try to replicate the same thing in the code. Okay, so I think then it will be easy for you whatever we discuss now. Okay, so what is it we are trying to say? Linear search. Okay, and actually don't sir, you might have already told me that, or Harish, okay, you might have already told that you are going to teach in C and Java, right? The data, so don't just you don't worry about that. Okay, the logic remains same in every logic, I mean every what do you call, whatever the language, right? So the fundamental, I mean, the searching or whatever it is, right? Whatever the data structure is, the logic remains same in any language. Just the syntax might change. Okay, just the syntax might change there. Okay, now let's check. What are we going to do? We are going to give an array. Okay, a sorted array. Sorted array in the sense starting with 5, 1, 2, 3, 6, 10, 30, 40, and 50. Okay, now this is an array, right? So let's give it an array. Fine. So now you wanna target. What is a target or key? Okay, we'll say target or key we want to search for 50. Okay, so what are we going to do here? So we are going to write a method, right? So what are we should return, what we should return, we should return an index. Okay, index of that key which we are searching in this array. Okay, so what are we going to pass? Array we are going to pass, and we are going to pass the key. Okay, now if you check it, So it will ask us to write that method, static method. It will write, we can write, I mean it will declare that. Okay, so fine. Then what are we going to do next here? So we will try to write a for loop. Okay, for int I equals to 0, I less than, so until when are you going to search? Until the array length, right? Until the array length you're going to search. What is the array length here? 0 1 2 3 4 5 6 7, right? So until that length you're going to search, until that I is reaching the last element of an array. Okay, you're going to search for that. Okay, if array of I is equals to the key which we have passed. Okay, key what we have passed 50, right? If it is found, we are going to return the index. We are going to return the I, or generally, so in terminology we should not use this I or something in real world, but we can say index. Okay, so we'll say index. Okay, we are going to return this index. So what is an index here? So index is nothing but for this is the 0th index, this is the first index, this is second index, third, fourth, fifth, and sixth. So this is 0. So first 0, first 2, third, 4, and 5 and 6. Okay, so so okay, let me actually change this also. Fine. Now just look into this. So if it is not found, what I said, if element is not found, we are going to return -1, right? We are going to return -1. If it is returning -1, it means that the element which we are trying to search is not found in that uh, array. Okay, fine. I'm just trying to print the index here. Okay, now 50 is what index? 50 is at the sixth index. Okay, now let's try to debug this. What is happening inside this? Okay, now let's try to debug. Okay, so what is happening here? I'll add a debug point here. So what will happen here? So you get an array, you have passed the array as this whatever the values, right? You pass those values, right? 1 5 6 10 30 40, right? That array is passed here, and the key to search is 50. That will be passed here, right? And then what will happen? This will be passed here. Then what will happen? You're trying to search for that index, right? So if you check here, you can check that. Okay, so what will happen exactly? It will reach to this position, an array of 0. First array of 0, array of 0 is what? 1. Is 1 is equals to 50, which we are trying to search? No, right? So it will come out of that loop. Sorry. So what is, so array is 1 5 6, this one, right? So index is 0. Index you started with 0. So first array of 0, what is array of 0? Array of 0 is 1, right? So uh, if you just true this one, right, you'll get to know that. I'll do evaluate expression here. Array of 0 is 1. Evaluate, what will happen? Array of 0 is 1. Just trying to collect, array of 0 is 1, right? We found 1. Is 1 is equals to key? What is key here? 50, right? Key is 50. If you check, key is 50 here. Is it equal? No, right? It will not go inside this if loop. Okay, so next we is checking index. Now index has, I has become 1. Okay, I has become 1. Now it will check now whether I less than 1 is less than array dot length. What is array dot length? Array dot length is 5. If you check, array dot length is 5. Okay, sorry, in this case it is 7, right? Now it will come inside this uh, for loop again. It will check array of 1. What is array of 1? Array of 1 is 5. 5 is comparing with the key 50. No, right? So it will try to look for each and every, uh, it will try to compare with each element in an array. That's why we are scoring as linearly searching, right? We are saying linearly search. Okay, sequentially we are looking into the one by one element of that array, right? So, and we are trying to until it is found, it will. So now the array is, I mean, index is 3. 3 is not equals to that. Array of 3 is what? Array of 3 is 10. 10 is equals to 50? No, right? Now it will go to the next step. Array of 4. What is array of 4? Array of 4 is 30. 30 is equals to 50? No, right? Next time, array of 5. Array of 5 is 40. It will go inside this? No, right? Now, so if you check, there is, it did not went inside that, and we come out of this. Now finally, what happened here? Array of 6. Array of 6 is what? 50, right? Array of 6 is 50, right? And then it will now go inside this index and try to return that index. Index is 6. If you just check the console, what will happen here? Just check the console here. Okay, check the console. It will try to print the value. If you check the console here, the value is 6 printed here. Okay, so what is the time complexity of this linear search? The time complexity is, it is O of n, the worst case, right? Worst case, what are we going to do? So O of n, O of n is the time complexity of the linear search. O, big O of n, as we learned our previous, uh, and we have already seen what is big O notation, all these things, right? The time, so it is already implement, I mean, it is already represented in the form of the big O notation, right? So the worst case of this linear search, or the time complexity of this linear search, is O of n, right? So O of n is more costlier. So if you have, now for example, if you have millions of values, okay, in that million values, if you are trying to search for a key, what will happen? It will take more time to search for that key element, right? It will take, obviously it will take more time. So linear search is not recommended for the, if you are having a huge element. If it is smaller, if your array is smaller, the key which you are trying to search, it will be very helpful. But if you have a huge element, huge array or list, now if you want to search for that key, it will become, what will happen? It will become more, it will take more time, right? That's why we have something called binary search. So what is binary search? So what does binary search is? Binary search is a algorithm which is a, which is actually implemented in a sorted order. So what we'll do is, we will divide this array into, we will divide this array into half of that. Okay, now for example, I'll try to write the logic and I'll tell you. It will be more uh, helpful for that. Okay, helpful for you. Binary search. So binary search is a divide and conquer algorithm. Okay, it's a divide and conquer. What is divide and conquer? Let's look into this. Okay, so let's say you have same array. Let's take the same array. Okay, now what are you going to do? Just, we have same array here. So same array with the elements of 1 to 10 or something, right? So it is taking more time. Wait, let me type it. Nice. Okay, white 1 comma 5 comma 10 comma 30 comma, okay, it is, okay, 50 comma 60. Okay, so what is binary search algorithm? Okay, let's look into this. Okay, so, and you want to search for a target or key is 60. Okay, now let's look into that. Int, I mean, we are saying target is 60, or whatever the key is 60. Okay, now what are you going to do? You want to binary search, right? You want to search binary, so the method name should be, it should be readable. What are we so what are we trying to do? We are trying to do for the binary, we have to search, right? So array, and what you have to define is, you have to define two things here. What do you want to define? You want to define the initial element. What is the initial element here? Let's say consider as L. Okay, L is equals to 0. And let's consider R. What is R? R is the array of the length. Array of the length. Okay, R is the array of the length, or we can say the last element. Okay, array of the length. Fine. So it is, it has given, we have defined these values, right? And we want to return the index here, right? So key left comma R. Okay, so it is okay. Just give a couple of minutes here. So I just want to, I was trying to use some shortcuts to print that SOP, but it is taking more time. So in the meanwhile, what we do is we can actually try to, so okay, in the meanwhile, what I will do is here is, okay, just remove this. I just want to type that, and okay, so I just want to print the index here. Okay, so I just want to define the binary search here. Okay, this is taking more time. Okay, let me type, otherwise it is taking more time. Static int binary search. We want to pass the array, we want to pass the key in the left and the right, right? So what are you going to do here? So at the end of the day, you need to return the index, right? So what is binary search algorithm is, okay, so it will try to, so what we'll do is, first we'll try to figure out the middle element in this array, in this ordered array. Okay, so what is the middle element here? So let's take, so this is the 0, 1, 2, 3, 4, 5, right? So what will happen here? I will try to find out the middle element here. Okay, that is mid. Mid is nothing but, okay, in your left plus left. Okay, either you can do, what you can do is, you can say left plus R by 2 divided by 2. Okay, so what are we going to do here? What is your left? 0. What is your right? Right is array dot length. 0, 1, 2, 3, 4, 5, 6. 0 plus 6 by 2, your middle element will be 3. Okay, now, so this, where are you going to do is, this you're going to do inside any while loop. Okay, while L is less than or equals to R. Okay, you're going to do this. Okay, so what are you going to do inside this is, what is happening here? Declaration not allowed. Okay, fine. So if you were, first, what you have done, you have divided the array into, I mean, you have found the middle element, 0, 1, 2, 3, 4, 5, 6, right? So middle element in this case is 0 plus 6 by 2, I mean middle element is 3, so middle element is 30. The element which you are searching, okay, if it is equals to the middle element itself. Okay, if the key which you are searching is equals to array of mid, right, what are you going to do? You are going to return the, you're going to return that key, sorry, you're going to return the mid itself. Okay, so you're searching for like, let's say you're searching for 30. Okay, let's say you're searching for 30. Okay, so what is happened, you have divided a huge element and huge array into small, right? I mean, you have divided it, you're dividing your big array, you're dividing and you're finding for the next element, right? Now let's say, okay, what is happened here, what it says here, array of mid boolean, array of mid, array of mid, it says boolean. Okay, sorry, my bad, fine. So uh, so you're searching for key is 50, I mean, what is the key here, key is 60. You're searching for key is equals to mid is 30, right? So I'll try to print the uh, so I'm just trying to print the mid, but it's okay. I'm trying to explain you, but it's taking more time. So what is happening here, this is the array 1 5 10 30 50 60, right? So in this array, what is the middle element is 3. Okay, so it is taking more time here, let's leave it. Okay, so middle element is 3. So 3, I mean, the key is, what is the array of mid? Array of 3 is 30. 30 is equal to 60? No, right? Now we're going to, what are we going to do? We are proceeding. We'll proceed. What are we going to do? If key is less than the array of mid, if the key which you are trying to find is less than the mid element, okay, what are we going to do is, what is the key? Key is towards this side. Okay, so what are we going to do? You say r equals to, or what do you have, what you have to start where r equals to mid minus 1, right? So r equals to mid minus 1. Why mid minus 1? I'll tell you why mid minus 1, I'll tell you. Okay, so your mid element is this, and now if you wanna search, if you, whatever the element which you're searching is towards the left side of your left array, left side of your middle element, then what you have to do, you want to define r, right? This r you want to define mid minus 1. Mid minus 1, what will happen? Mid minus 1 is 2, right? So your r became, so you are divided it, right? You already divided, you're going to search that element in this row itself, right? That's it. Now if if key is greater than the array of mid, okay, if key is greater than array of mid, then what are you going to do? L equals to mid plus 1. What is L? Your first element, right? So now where you want to start, you want to start from this element, right? That's why your L will become this one, right? So L will become this, so 50 then 60, right? So in that way, so finally what are you going to do here? You're dividing and conquering it, right? So that's why. And if you did not find an element at the end of the day, what are you going to do? So you're going to return minus 1 here. Okay, now if you found it, what are you going to do? Return, sorry, 1 second. So if you found an array, right, at the end of the thing, what are you going to do here in this case? So let's debug this. So if key is array of mid, if key is array of mid less than the array of mid 10, right? So what is happening here? If key is less than array of mid, r is become your this one, right? Mid minus 1, right? Now, so what will happen? Your L is 0, it will go next to the loop, right? And then what are you going to do here? And it will search where is L. What is L here? L is 0, less than or equals to uh, r is r will become what? R is 0, right? R is, so okay, now let's take this case only, 60, right? So what is your mid element here? First of all, mid element is 3, right? Because 0 plus 6 divided by 2. Why 6? Your array length is 6 here. 0 1 2 3 4 5 6. Okay, so 0 plus 6 by 2, it will become 3, right? So mid is 3. Now key, what is your key? Key is 60. 60, you're comparing array of 3. Array of 3 is 60, you're comparing with the array of 3. What is your array of 3? Array of 3 is 30, right? It's not equal, so we're not going to return mid, right? We're not going to return mid here, right? Now, if key is less than the array of mid, if key is less than array of mid, what are we going to do? We have to return the I mean, what we should do is we should define, I mean, we should move the r to the mid minus 1, right? Mid minus 1, what will happen? So mid minus 1, so mid is this, so mid minus 1, r has become 2, right? R has become 2 now, right? So this r has become 2, but in our case it is greater than that, right? It is greater than that. So 60, key is greater than the array of mid, right? Array of mid is 30, right? 60 is greater, so we have incremented it. L has become, now L has become mid plus 1. Okay, now anyway it will not go inside this block, right? Next, what will happen next to L is now, L is 4 4 plus, what is the R? 6, right? So you have incremented, I mean, what I mean to say is uh, 4 plus, what we should do here? Your L has become mid plus 1, right? Your L has become mid plus 1. Let's look into this logic. Just one second, couple of minutes here. So okay, at the end of the day you're saying fine. If array of M is less than X, if array of M is less than X, we're going in a different way. Okay, I have written a different way this one. Okay, fine, anything is okay. So key is equals to key, whatever it is, right? This way or that way, whatever it is. So you're saying if array of mid is less than, I think I have done the same way, right? I have done different way. It's okay, whatever it is, its logic is okay. You just try to understand the concept here. If array of mid is less than the key, okay, what are we going to do? We have to define L equals to, if array of M is less than X. I think this is what I'm trying to say here. If key is greater, or this is what, both are same, right? So just remove this logic here. Okay, this other way, I mean, just return in the other way. If array of mid is greater than the key or less than the key, in this case it is less, right? So if array of mid is less than the key, right? 60 is less than the key. In that case, what are we going to do? We are going to move the mid plus 1, right? Array of mid is 60. 60 is less than the key. I have written a different way, but here in this case, array of mid is less than the key. You're going to define L equals to M plus 1, right? Else, what are you going to do? You're going to say R equals to M minus 1 or mid minus 1, right? That's what I've written earlier also, right? Or whatever, in that case, array of mid is greater than the key, right?